Hi, everyone. My name is Kurush Saraf. I'm the VP of Product Management at ZPE Systems. In this section, I'm going to talk about customer use cases for our Generation 3 out-of-band and how we automate remote critical infrastructure and edge networks for some of our customers. You see some of their hints of their names: rideshare services, a large social media provider, and multinational banks. So I'm going to just recap the journey of ZPE. We started in the large-scale data center automation, doing data center automation for these folks. They have their own equipment in data centers across the world. And obviously, the goal is to have this data always available, their service always running. And the issue for all of them is that the equipment is vast, the services are diverse, and human error, recovery, all of those aspects are, and uptime is obviously of utmost importance. It's their business. And how do you achieve that? So the gaps were in terms of automation, how do you run all the tools, and how do you make sure that when you run all those tools, the infrastructure is secure? So security is definitely an aspect in their decision criteria. The solution is fairly straightforward for the folks that are data center folks. Imagine rows of data centers. There is a serial console device at the top that hooks into all of the equipment. There's also the Ethernet side of things. And the goal really is to do this end-to-end automation of the entirety of the rack, everything from the power supply to the switches, routers that are in there, even sensors that detect airflow and dust and various environmentals to make sure that preventive measures are taken so the equipment doesn't go down. And to be able to do this at scale, we needed to give the tools to sit on top of this serial console to run Docker or VMs or Python scripts, whatever the customer wanted, right? So that was the ask. But the differentiator and why we win these deals is, one is the port count, right? We have a high density, and each of those ports has very deep buffers. So when a server fails and does a last gasp, you don't want to lose all of that troubleshooting information, right? So one of the asks was, all of this data that's being generated, don't lose it, and really important. The second one is that we have a Intel-based CPU, which allows us to then say yes to anything that somebody wants to run on the system. And obviously, security is another aspect, both on the software side, but also on the hardware side. And one aspect that many of the tech giants are worried about is an area that's called supply chain risk management, right? It's a whole category in itself where if the equipment gets intercepted or tampered with, or there's something that is not supposed to be there, how do you know that, right? How do you make sure that this infrastructure is, or this piece of equipment is really what it was intended to be, and there is no extra hidden things in there? And that's one of the things that we have developed from the root up in terms of secure deployment and a zero trust hardware stack. And we can answer questions about that as well. And then in terms of automation, everybody wants to hook this infrastructure into the automation tools that they already have. And so that's where Chef, Puppet, Ansible, Python, anything that you want to throw at it, we can say yes to.
Sorry, you can go back.
Yep, absolutely.
In that slide, it talks about you're applying patches to the system. Within 24 hours, you have the Log4j addressed. How are you doing that, and how are you securing that channel? I assume you're doing the patching, not supplying it to the end user.
The first part is for us to be able to know about this and have our software patched quickly and ready to ship out. And so that was done in really quick. I think we were actually pretty surprised how quickly we did this patch and released it to our customers. And then the customers that are cloud managed, that actually becomes available right away, and they can push it down to all of their boxes.
So you have both cloud managed and I assume non-cloud managed customers?
Correct.
So we have customers in the data center, right? So they typically don't allow us to touch their boxes. So for them, right, we made available the patch and the workarounds and all the instructions right away in our gateway server, so then they could download and apply through the automation tools that they have, apply to the data center. And for boxes that are used in the edge or remote locations, we have cloud management, right? The OS with the patches became available there as well. Then they could push through the cloud management to their remote location. So that's the way we address it, right? We take it very seriously, right? Any type of security, we tend to respond quickly, right? That's a big differentiator of the company. And even if we don't have a fix immediately, we put out workarounds or alternate ways to protect the system, and we felt quite happy with the results and with the response that we gave on this last security breach.
So that was about the data center, and quickly just reviewing our solution there. Now, the next ask was to take that capability and push it to the remote edges of the network, the branch offices, manufacturing locations, just critical infrastructure that these companies have. And that is different, right? It's the same ask, but it's a different set of products that are needed. And so to just talk about why that's a bit different, I wanted to just tell the story. Most of the delegates here have been doing networking for 20 years plus. So they remember when networking was simple compared to today. Networks were turnkey, just buy an MPLS link. The data lives in the data center where it was supposed to live. And things were straightforward compared to today. Then cloud and edge came along, data went everywhere. People started to work from other locations. Data was pushed to the edge. You had broadband and 5G, and just this networks became hybrid, distributed, do it yourself, and then a whole bunch of things were needed to make that happen, right? You needed the security pushed to the edges of the network versus central. The SD-WAN became a thing to make sure applications work properly. Then out of band to remotely troubleshoot things, sensors. What else is on here? IoT stuff came about. So, and then edge compute, right? A whole bunch of things now have to be managed at these edges. So it's actually a lot more complicated to put your arms around all of this equipment and solve all of these disjointed systems that are out there. And so that's essentially what we said that we want to address, is to modernize the way that the edges are deployed, where we can still say yes to the technology that the customer wants. You're not locked into a vendor. If you want to buy your firewall from us or from the other vendors, you can do that. But we give the platform that is managed as a system, as a single unit, and the pieces that you want to run on it is the customer can choose, but we still bring our world-class out-of-band management into the picture. Now, I'm going to show what that looks like using some of the customer deployments. The customers that we've selected here, just to give some diversity: retail customer with 1,200 locations, a credit union with 90 branches and a lean IT staff, a tech giant, hundreds of warehouses that obviously need to be operational 24/7, and a university campus, right? They all have environmental commonality. By nature, these are remote locations, hard to access. The equipment in these locations is heterogeneous. And then there is a desire to run network as code, right? Or get NetDevOps practices in there and achieve that level of automation and ultimately orchestration so that the entire thing just works. Some of these customers are managed by MSPs, right? And so MSP, it's costly to roll a truck, and you oftentimes after a couple of truck rolls, you lose money on that site. So how do you then make sure that a branch is always running and then be able to prevent it from going down and remotely recover? The other aspect, obviously, is that all of this equipment is in a critical location. It's critical infrastructure. So the same theme that was true for the data center is also true at the branch edge. So first customer, retail newsstand. This is actually from the deployment diagram that I just grabbed for this slide. There's a different set of equipment in there, from the power backup to power control to audio system, and then your L2 switches, gateway. And the problem that the customer has is, if again one of these sites goes through an upgrade and doesn't come back, then a truck roll is quite expensive and really costs money for the business in terms of downtime. So we have a node grid bolt in this deployment. One of the attributes is that it's connected to all of the different pieces of equipment using various technologies. And this is a good example of the ecosystem model, where the audio system, as an example, you have to connect with it with a web interface, I think. And then there is the USB VGA. There is serial. There's and then on the Meraki that's in here, it doesn't have a serial consoles, and when it's broken, you need to get to its web interface and recover it. It's the same diagram as you saw previously. So our equipment sitting there is able to manage all of this equipment and then use its LTE for the out-of-band connection. And the customer is also able to use the LTE 4G for data as well. So it's a dual-purpose system, and very, very small box that we call the Bolt. Building on top of that is the credit union use case, where they have now a data center, a branch, and ATM machines. So they need different pieces of equipment to manage this, but they all managed from the same system. And again, lean IT team. The goal of all of these customers is to really realize this dream of automation, which is usually for servers and cloud, because they're all Linux based. And now we've brought that to the infrastructure, where you can run the same Python code that you're comfortable with on our systems. So this is connected to ZPE Cloud, and in ZPE Cloud, we have a repository of automation scripts. Renee is going to actually show that and even take that further with Ansible. And this customer is able to save $1,800 for every truck roll that they don't have to do, and really have all those branches up and running all the time. And to the question that was asked on Docker, so this is our NetSR product. It's modular. Those ports in the front, some are serial, some are Ethernet. You see the cellular modem in the middle. We can also have compute cards in that device. So it's got 5 modular bays that you can choose what's suitable to your deployment. And with the ability to run third-party code, the customer is able to use their private orchestration system, put those Docker containers on our product, and then control all of the different aspects of our product, which then controls all of their branch operations. So a very true example of end-to-end automation that was not possible before, because at a branch and to control infrastructure, you need networking equipment as part of it. It's not just server automation, and this box has all of the right pieces and capabilities to deliver that.
In looking at how you're combining all this together, with a cloud to manage it and manage the automation, do you get to pick the cloud that you're putting this on? Like if I'm an AWS shop and I've got some physical data centers and I've got my AWS stuff, and AWS has a bad day, how does that work for access, since this is targeted to be an out-of-band management solution, which you're trying to make resilient?
So maybe you can expand on your question. Is that the customer's cloud is having a problem, like their services, or is
your platform is that? Do you have the option to host that yourself, private cloud, yes, whatever? Do you guys have your choice of cloud, yes, that you use as you're offering the service, so that just for example, like if you guys use AWS, I use the AWS, my Oregon AWS has a bad day. Yeah. How do you defend against that challenge?
So there are actually 3 solutions that we have. Because we started in a data center, right? That was, cloud was not even a choice, right? As a data center, you need to have on-prem management. Then when we did the edge, we offered the cloud delivered management. And then exactly to your question, the customer said, actually, we want a private cloud, right? And that's what we also have. And that probably is a first for this type of a box, to have the same ZPE cloud that we host. The customer cannot take that and host themselves.
So I guess it is or is not able for the customer to put that into, or do they have a choice of where it goes to diversify?
They do. Yeah, it's
got it. Okay.
It's a packaged private cloud, and then the customer has a choice of to run it hermetically if they want to, right? Mm-hmm. And so if you want in-country cloud, you can certainly run our ZPE cloud hermetically in where the customer wants it.
I think that's it. Right, we do have that on-prem solution, right, for exactly those type of scenarios where you need to deploy, but you also want to control, right, the content of the cloud under your premise. So we do have that offering. We also have the offering on the cloud, and then the solution at the data center for management. So all three options are available.
All right, and then just to put this together in a nice graphic, all of these deployments, be it at an edge micro data center, even under a cellular tower with 5G towers, all of those tower locations are now being are hosting edge workloads. So enterprise branches, critical infrastructure, even in a mobile fleet, this portfolio of boxes is able to not only do the out-of-band management to increase availability, but this whole open ecosystem and a friendly platform for automation. And for the type of customers that we are dealing with, the security being so important that the zero trust hardware, software, and the seed-of-life provisioning, where a box is shipped blank, and then they provision themselves if the box is trusted all the way up to fully deployed, is that unique selling point that people select our boxes for. In conclusion, I wanted to just recap everything from the start. We said reliability. One of the asks is this end-to-end automation, and what we provide is this open ecosystem, open x86 platform, and the harmony that we bring into the environment so that everything works together. The other one is just making the whole thing simple to realize, right? So the centralized management, the versatility of the hardware, and really our mind is that give the customers and the ecosystem partners this all the capabilities so that we can journey towards AIOps together. And then finally, the security aspect obviously is, we've been talking about that quite a bit. Everybody else has been talking about that quite a bit. But to get that complete security, from the very start, the hardware needs to be trusted all the way up to the software, the latest security patches, and all the different attack vectors need to be accounted for so that the infrastructure is as robust as possible.